So here we got a problem. F of x is trigonometry, g of x is a line. Yes? And I said, well, even before you start the problem, try to use, some technique, trick. This way, things are easier, right? So you look at this problem, you should always ask, well, is there a trick that I'm missing? Alex, spotted it. Some of you did it and got the answer, which is good. Some missed it. If you missed the trick, nothing wrong, we'll still keep it as is. But you have to know an integration technique to get to the correct answer. That said, in a problem like this, first we've got to find the point of intersection. Well, where would these two values equal to each other? Well, x is 0. If you put x is 0, g of 0 is 0. Agreed? F of 0, 0. Agreed? So, at x is equal to 0, f of x is equal to g of x. So great, I got my first point of intersection. Onward to the second. You were having difficulties recognizing it directly because of that. But if you use the trigonometric identity, this can be simplified. What is that identity?
Sine 2x.
Very good. Sine 2x is 2 times sine x cosine x. Correct? Don't forget that reference table. Divide by 2 on both sides, sine 2x divided by 2 sine x cosine x. Good so far? Okay, doesn't matter which approach you take. So either I can do this. I know the lower limit guaranteed 0 point of intersection. So upper function, lower function. G of x is going to be on top. I just know it. So 8x over pi minus, keep it as is, call it sine x cosine x. Or 0, 8x over pi minus sine 2x over 2. Good? Which seems relatively easy. This will all help. This. At least in my point of view, of course, opinions differ, but I personally think that is a better way of doing it. Now, the next question is to find or is to ask is the upper limit. What is it? Well, we want to find another point of intersection. In other words, I've got to find a place where that would equal that. Correct? Yes? Okay. The first function is sine 2x over 2. I just rewrote it. The next function is 8x over pi. Yes? Set them equal to each other. Sine 2x over 2 equals 8x over pi. I already know x is equal to 0 is a point of intersection. From here, it will satisfy the equation here as well, if better, or else my life would be meaningless. 8 times 0, 0, outside 0, sine 0, 0, 0 equals 0, check. We've got to find the next one. So to do that, sine 2x equals 16x over pi. Good. What is the maximum value that sine could take? The highest point. 1, right? The highest point that sine could take is 1. The lower value would be -1. If you want to get 1 here, what should you put? 1/2. It's sine. What value should go in there so that I get 1 on this side? Pi over 4. Sine pi over 4 is 1/√2, but 2 times pi over 4 would be pi over 2. What is sine pi over 2? 1. Good. So at its highest point, that's the sine that we're looking at. Value is 1. Happens at pi over 4. Let's see what happens to the line at pi over 4. So line is the other side. Plug in pi over 4, what do you get? That's easy. That's right.
4 pi. 4 pi.
4 pi.
Oh, sorry.
So pi over 4. You'll get pi's will get cancelled. 16 over 4, you will get 4. The other curve is off there. So starting here, it's going that way. Good. So could it intersect? I don't know. Do you think it will? Lorenzo, you're shaking your head.
Sine is a repetitive function and it's
Exactly. Trigonometric functions have a period. They repeat, correct? This function keeps on going up. The other one, can I erase this bit so I can draw? The other part of it will turn around, come this way, go back that way. This value, where it becomes 0, would be pi over 2, and that will be pi. Yes? And that's just going up. This change, so no matter where you look between 0 and pi, aside from 0, it is not going to intersect again. Good? But in this problem, they have given us the other endpoint. So, do I have an enclosed area? I do. This line goes all the way up, down, whatever area you have would be the area that we're looking for. Good. So I'll just do a rough sketch so that you know what the area is before I go to the calculator. So 0, pi over 2, pi. This would be pi over 4, 3 pi over 4. At its highest point, we had 4 up here, so the line's going this way. So good. Regardless of where you look, upper curve, lower curve. Good. So one may ask, well, what if the intersection happens right here? Well, that area is negligible, extremely small. Do you agree? Right at that point, it's really close to a point. It really doesn't matter. Very small area. So that's what we need to. And it doesn't matter which way you integrate, the answer will be the same. Can I erase this picture? if I start here, you got stuck because you forgot that you can't split this integral. Why? Function added to function. The only time when you can't split an integral if they are multiplied, the functions are multiplied, or if they are divided. But here it is in some difference, so I can split the integral. 8x over pi, 0 to pi, dx, minus 0 to pi, sine 2x over 2, dx. Good. What is the first integral? He's having difficulty following his own answer.
Well, yeah, that can be sure, but
8 over pi would come out. Yeah. What is the integral of x? Easy.
that's great for two.
X squared over 2 minus 1/2 comes out of the integral. What is the integral of sine 2x? Is it negative cosine 2x? Okay, is that it? Okay. You get to have your cheat sheet now and then. I'll mention some tricks, so go ahead and write this in your cheat sheet. In general, good. Well, how did we get this? Well, let's just use substitution. But, it's easier to do the integral such as this if you know the identity. In our case, b is 0, a is 2. Good. Times it by the limit. Plug in the upper limit, I get pi squared, so 8 over pi times pi squared over 2 minus 1/2. Plug in the upper limit, what is cosine 2 pi? -2. Cosine 2 pi. 0 or 1?
It's one.
1. So cosine curve, that's 1. So upper limit, I'll have minus 1 over 2. What is cosine 0? Period of 2 pi. If it is 1 at 2 pi, what is it at 0? No, sorry, right? Sorry? Yeah, 1, still 1. So again, minus 1 over 2, but lower limit, upper limit, minus lower limit, minus pi. Good so far? Well, minus of minus would be plus half, minus half, gone. Agreed? Pi, gone. 2, 8, join, the answer is 4 pi. Good. Now, if you didn't do the trigonometric identity, if you kept it as is, the first integral, this part, not a big deal. That's not going to change. Same answer throughout. But what about this part over here? You have sine x times cosine x. So just a side note here, we already have the solution. If you refuse to use the trigonometric identity, can I split the integral? I cannot. Functions are in product. So there has to be a different trick or technique that we have to use. You're refusing to use trigonometric identity. So what is the other technique that we can think of? You need both. Use substitution. In this case, doesn't matter whether u is cosine, u is sine, doesn't matter. So I like saying, so u equals sine x, du over dx. Waiting.
Negative cosine.
Negative cosine, positive cosine. They're taking the derivative, not integrating. So du is cosine x dx. Yes? Okay. U, du, agree. Here's the catch. I have seen students carry this limit till the very last step and then put x in, then put the then apply the limit. That's okay. I will not recommend it, period. At least from my experience, as I learned a long time ago. It is better to convert the limits right away. You may ask me why. You go to differential equations, you may have to integrate multiple times. And perhaps you have to do multiple u substitutions. You will lose track of things. We don't want that. So the very first step would be to change the limits. Do we know how? U is sine x, 0 for x. If x is 0, what is u? Sine 0. What is sine 0? 0. X is pi, u is sine x. If x is equal to pi, what is u? Sine pi. What is sine pi? 0. Interesting case, right? You start at 0, end at 0, you find the area under the curve. How much area have you got? Alex? Nothing, right? What is the area of a point? An infinitesimally small point. 0. 0. Which we have right there. It's sort of a give and take. It's this particular approach, easy from the start, but requires a bit of work there. That starts kind of tricky, got to know the technique, but produces really fast. Does that make sense? So that's it, got the answer. So it is a matter of choice. I personally prefer that one. Did you change your mind after seeing this? Or are we sticking with that? Sticking with that. This one, matter of choice. Okay. First equation is easy, 8x divided by pi. So 8x over 5. The second, either you could put sine x cosine x, or you could do sine 2x over 2. Entirely up to you. You tell me which one you want. I'll go with that. Now's the time to speak.
Sine, cosine x.
Sine x cosine x. Okay. Sine x. Cosine x. Good. And graph. Another tip, trick. Anytime you have sine and cosine, you've got to remember its domain and range. So the initial period that we look at, 0 to 2 pi. On that interval, sine, cosine, what is the maximum value of sine, cosine? 1 minus 1. Why am I bringing this up? Look at that picture, pretty messy looking, right? You've got no idea as to what's happening. Have to adjust the limits. So I know I'm going from 0 to pi, so let's change our endpoints. Maximum x value is pi, minimum 0, y minimum 0, maximum, well, if I plug in pi in one of the equations, I'll end up getting a, the linear function. So we'll just leave it at 10. Good. That would cut things off here. So let's change that part to -1, because we know the lower limit would be -1. Now let's graph. There is the upper function. Slowly it's moving. There is the lower function. Skillfully done. I did it, in a poor manner because I'm no artist, but I tried. This is the part that I shaded earlier. Good. Okay,